Next, find the general solution for this dE. First, we check, express the dy dx as a subject. As we move this term back to the right hand side, it will be plus 2 over xy. Then we can notice that we can't factorize anything. We can't factorize a y. So y is attached to x, means this x and y cannot be separate. When we having non-separable differential equation, so the other way to solve this dE is by using integrating factor. So our strategy here will be using simplest. So for the first S is look for your standard form, where we're going to start with dy dx as a first term, and then plus the term of y in the middle, and then equal at the right hand side the remaining term. So from here, actually we want to identify what is our px, which is what is our coefficient of y, which is 2x. Then we move to the second step, which is I. I is finding integrating factor, where Vx is equals to e to the power of px dx. So plug in our px, which is 2 over x dx. Then the integration will be happen at the power here. So to integrate that, we factorize 2. We integrate 1 over x, which will bring us the formula ln x. Then as you can see, e to the power of ln, it can be simplified. Before we simplify, we're using the properties of log. 2, we have to move back for x to the power of 2. Then only the ln can be simplified. Therefore, the integrating factor here is x squared. So the following step, it will be n. N is multiply back the integrating factor back to the equation. So it will be x squared dy dx plus. So for this step, we just need to rewrite it in multiple form. So multiply each integrating factor back to the equation here. Then for the next step, it will be P, simplest. P is writing product rule. So how to write product rule? It will be d dx vx times y. So vx is x squared times y. So for this left hand side, we managed to write it in product rule. So for the right hand side, we remain it. Then for the next step, it will be I. I is stand for integrate both sides, so that we can get off of this dx to find our solution. So integrate this with respect to x. So differentiate and integrate, differentiate and integrate cancel each other. It will bring us back to solution. So the next step here, it will be general solution. So for integrate this, x squared over x minus 1, since our denominator is not one term only, and we notice here our fraction is improper fraction, means we can simplify. So to integrate right hand side, we will simplify using long division, as we have improper fraction. So for x squared divided by x minus 1, what we need is another x, so that we can get x squared. Then balance here, minus 0 minus negative x become positive x, and we still need 1 to time with x, so that now balance is remain 1. So for the right hand side, now will be integrate quotient x plus 1, and then remainder is 1 over x minus 1. So we just simplify our long division here in the pattern of quotient plus remainder over divisor. Now we can look at our equations here, where integrate x, it will give us x squared over 2. Integrate 1 will become x, and integrate fraction in linear, it gives us ln. Then lastly, plus c. So we simplify this as our left hand side y have to become the subject. So we divide the x squared. Here we have 1 over 2. And when x divided by x squared, 1 over x. So here will be ln divided by x and c divided by x. So for c divided by x squared, so divide by x squared, yes. So for c divided by x squared, we can't simplify, become a. So we'll remain it as c over x squared. Why? Because c is a constant, but x is our variable. So we can't simplify it as a constant a. We'll remain it as c over x squared. So look at the question. So they didn't give us any value. Therefore, our final answer, general solution, will be in this equation.